It's something that we all experience daily is, how our traffic works and how our freeways and intersections work. And to be able to develop something that maybe moves the needle a bit is fun. And to integrate new technologies and as they come available is exciting.
Hey everybody, welcome to another Pulse podcast from Wavetronix, where we talk about everything transportation and traffic. Our special guest today is Bryan Jarrett. He is a seasoned engineer and algorithm specialist whose career spans both large-scale corporations and innovative startups. After earning a master's degree from Brigham Young University, where he completed a thesis on synthetic aperture radar under the mentorship of David Arnold, Bryan began his professional journey at Hughes Missile Systems, later Raytheon Missile Systems. During his 6 years there, he worked as a writer, analyst, and algorithm developer. And in 2001, Bryan joined Wavetronix. Bryan, thanks so much for being here, chatting traffic, chatting radar, maybe other things that you want to talk about?
My pleasure.
Yeah. I'm curious, if we go back in time before radar in traffic detection, what was being used?
The first technology was just embedded loops, inductive loops in the ground, and when the car would go, something metal would go over them, the inductance would change and the circuit would create a detection. And then video came in, and people liked video because they could see it from their operations center, but it wasn't very accurate. The lens had to be cleaned, and when they're shadowing, and it had a lot of struggles. And then radar came onto the scene.
And I guess everything has its place, right? And inductive loops are great, but they have their limitations. Video can be great, but it has its limitations. What was so revolutionary about radar?
Yeah. Well, first, inductive loops in some places do really well, but they suffer whenever there's trenching. If it gets hot and cold, freeze-thaw cycles will raise them up, and when it gets really hot, it has problems. So radar is out of the road, and it's pretty much an all-weather technology. It provides the most robust performance of a non-intrusive detection technology, at least at the time. So.
Yeah, I've talked with signal technicians in different places where they have struggled with cameras, be it fog or snow impacting the lenses, sun glare. Radar doesn't have issues with weather?
The radar will see through fog, rain, snow, those type things. Yeah. It can have some issues with things on the road, but it sees right through anything coming through the air.
And so if we go back to when you first started at Wavetronix, what attracted you to Wavetronix after you were doing what you were doing previously?
Well, I was in a company that had 100,000 people, and I had a very important role in a division of that, where we did simulations so you don't have to fire missiles and blow up planes to see how the system works, and so we modeled things well. But I'd got an MBA, and I wanted to be in the commercial industry. Defense is a lot different with contracts and government spending and government decisions, and with a product like radar and traffic, your performance can provide greater demand.
What did you first work on when you came to Wavetronix?
I started out in what was traffic labs, and Brad Giles and I were working on modeling traffic, and the idea was to predict traffic like you predict weather. It's going to snow today starting about noon, or your evening commute is looking a little rough. There's going to be a football game or whatever. There were a lot of equations that are used to model when traffic will break down. And traffic is kind of interesting because you put cars on the road, and the more cars you get, you get more flow through the road until you hit kind of a breaking point, and then all of a sudden everything slows down. And so you put more cars in, and speed is good, and then it just breaks down, and all of a sudden your system is kind of broken, and you're not getting much through on that freeway or whatever you're looking at. And so there are a lot of ways to model that, and so that modeling kind of flows into traffic theory and signal coordination, ramp metering, and those type of things too.
So systems have to be dynamic to deal with that?
The industry is kind of divided. I mean, the typical plan is based on time of day, and there are some adaptive plans that will adapt based on demand, and even time of day plans will it's timed, and you'll have like a protected green, and then it's based on demand, and it can transition within the next whatever time period, maybe 20 or 30 seconds or whatever, if there's no demand, and then it depends on the demand on the opposing approaches as well.
And when we talk about radar and traffic, there are different aspects, different products, and different applications of radar. Explain that to me. I mean, there's highways and there's intersections.
Right. So on highways or freeways, you're really trying to measure. First it's counting and classifying and measuring speed, and DOTs submit reports to the FHWA, and that rolls into funding based on how many cars are out there. But also understanding the demand and all your trip time signs, 30 minutes to the airport, 60 minutes to the airport, all those things are based on what the traffic flow is at the time. And so speed is important. And then when you pull in ramp metering, where you're saying, hey, let's not overload this freeway, then it can be pretty important to have fairly accurate speed and occupancy of the road, or how much of the road is occupied. And so detection using radar can answer that.
And then getting into the intersection, there are still multiple products for intersections, right?
Yes. So in intersections, again, you have loops, and you have video, and probably a myriad of other technologies. And there the application or what the product needs to do is first communicate to a controller when there's demand. When there's someone at the stop bar, oftentimes they'll want to know if they're 4 cars back, or how big the queue is, those type of things. And then the other feature that is common is advanced, I want to say preemption, but advanced detection, where if you're detecting a vehicle coming to an intersection, you want to hold the light green when they're in what's called the dilemma zone, which is defined to be like 2.5 to 5.5 seconds. And when someone's in that zone, it's hard to predict whether they will go through or stop. And which is fine if it's just a single car, but if there's someone behind them and they think they're going through, and the car in front of them thinks they're going to stop, then you have a conflict. So it's safer to wait to transition to yellow or amber when those zones are clear.
So are loops or cameras going to be able to help with that dilemma zone?
Loops, you can set up a speed trap. Typically, they set loops, advanced loops, and it's based on an assumed speed. Supposedly, you could do a speed trap and measure the speed. I don't know if there are systems that are that sophisticated with it, but loops can do that, and cameras can do that as well. As far as there's someone at a specific point. So you can protect a dilemma zone, but dynamic dilemma zone means based on that vehicle's speed and where it is. And radar is the best for that, because we measure distance and speed.
So we're talking about the advanced sensor.
Yeah.
And tell me what is unique about that which enables it to do this dynamic dilemma zone detection?
Well, it's measuring, like I said, the distance from the vehicle to the stop bar at any given time and its speed. And so it calculates its time of arrival to the stop bar. And then you can have a zone that you're protecting, like typically, say 2.5 to 5.5 seconds. And you send a call into the controller and say, hold off on transitioning while there's a car in here. And eventually the controller will time out, and so there's no guarantee that if you're in the dilemma zone that you get to go through, but it can be safer for most cars.
Yeah, you can't leave that approach green forever.
Exactly.
At some point there has to be a red light. And that's the whole goal, right, of what's being done is to keep it green. You hear that a lot, keep it green, keep people moving.
Right. Well, there are two main goals in the traffic industry, and one is efficiency and the other is safety, and you don't want to sacrifice one for the other. But with advanced detection, you can also find gaps when it is safe to transition, and sooner than you otherwise would. So I think dynamic dilemma zone is a good solution.
Yeah. Are there both pros and cons to radar detection? We're talking about a lot of pros.
Yeah. So as far as cons go, I mean, radar does not see over or around vehicles very well. So you'll have occlusion, and sometimes there's multipath where signals bounce around between cars, and you can get a phantom image. So it's not perfect, but the performance is good.
And then this is something that the general public has no clue about. They just drive the roads and they want green lights. But what do you think the impact has been on just the general public as far as radar traffic detection?
Well, radar is part of a system, and then I've seen and driven in systems with radar and good systems, and traffic flow is much better. And you go to other states, and it's a little more frustrating, to drive through those roads and say, "Oh, why isn't this giving me the green? I should have a green. I'm looking around. There are no other cars here." But as part of a system, radar can be a very valuable tool.
Is there a difference between good and bad radar?
Yeah, sure. And that's going to come down to performance and how well it detects and how robustly it detects. The resolution. I mean, early radar had very poor resolution, and some radar systems had difficulty detecting cars near a median on a freeway, and improved resolution and our algorithms can be implemented to address that. And so, I mean, radar itself is pretty basic, and what I've seen is it takes a lot of effort to get high performance out of a radar, and so that's spending a lot of time on algorithms, and it's like building a house. That last 10% provides a lot of value, and that extra effort to get the accuracy up makes a difference. So
Wavetronix wasn't first on the scene with traffic radar.
No, there was a company, EIS, and their product was the RTMS. Sorry for all the alphabet soup. And their system was first on in the industry, and they did a very good job of opening the market, of selling the opportunity to have non-intrusive detection. But their system was, it struggled. It was poor resolution. Algorithms weren't as sharp as ours. It would take a half a day to configure a sensor, and then when you come back in the afternoon, the configuration was bad because the radar itself would drift, so that the beam width or bandwidth, that you're transmitting would change throughout the day based on temperature, and so a digital system locked to a crystal that, like we started with, gave much higher performance. We called it digital wave radar at the time.
Yeah. I'm curious about going down that road. We're talking traffic, right? How have you seen, or what is maybe the most dramatic innovation that you've seen from Wavetronix over the years? I
was with David when he was out at lunch with some investors, and I think the original idea with Wavetronix was, hey, let's create a radar for the intersection, which proved to be a much more daunting task. At the time, we used a lot of off-the-shelf components, and the parts that you would want to do that weren't necessarily there yet, and the technology that we wanted to use wasn't quite ready for that. And so moving to a switched beam antenna system where you could now differentiate in angle and range it's a very robust solution and provided very good performance for that market. So on the radar side, matrix was the biggest jump probably to date. I mean, now we have XP21, which will do a 4-approach intersection, a smaller intersection with a single sensor. So that's another big jump, but we're just at the beginning part of that release. So kind of wait to see.
Yeah, and that's pretty huge. And it's my understanding we're talking about David Arnold, our CEO. Was that his original hope, his original dream, to have one sensor detect the entire intersection?
Honestly, I don't remember. It might have been just one per approach, but
Okay.
maybe it might have been one for an intersection. I don't know.
Yeah. And now to see that, though, single sensor, all 4 approaches, I mean, do we just take that for granted because this is what you guys do all the time? You're innovating, you're developing, and then you move on to the next thing? Or do you sit back and say, wow, that's pretty amazing?
Yeah, it is a pretty compelling offering. It doesn't necessarily have all the bells and whistles that our single approach sensor has, but to put something up and configure an intersection quickly, and that's very appealing, I think, in a lot of areas.
Yeah, and depending on the intersection, it's a perfect solution.
Yeah.
Right.
Yeah.
Other times you might need the matrix or an advance.
Yeah.
Is there future innovation for radar in traffic?
Absolutely.
Do you know what that is?
I have some ideas. Yeah.
Yeah.
Yeah. We're working on new stuff all the time. So we want to advance our offering and provide more to the customer and provide better value for the road users. And the opportunity is there. Technology is growing. The tools that are available are expanding significantly, and so we'll make use of those.
Will it incorporate autonomous vehicles and V2X and all this stuff that's been talked about for a very long time?
It's not released yet, so
top secret stuff we can't talk about, huh?
yeah, things don't plan on what's not there yet. So we'll see.
Yeah. Okay, that's very good. How, when we talk about radar and what we've accomplished at Wavetronix, and it's been innovative, how reliable is radar in the traffic world?
Well, I don't know how you define reliability. It's you're not likely to miss a vehicle that's there by itself, and again, it's not perfect. If you get wet snow kicked on the sensor, maybe you don't see perfectly, but we have visors now to limit that risk. But radar in general is a very robust solution.
What is in it for you? Why are you this invested in traffic and radar and detection and all that?
I think it's a fun problem to address. I think, it's something that we all experience daily is, how our traffic works and how our freeways and intersections work. And to be able to develop something that maybe moves the needle a bit is fun. And to integrate new technologies and as they come available is exciting.
I think most people want to have an impact with what they do professionally. You'll never know your impact because it affects everybody who's out there driving underneath one of these sensors.
Yeah, it's statistical at that point, right? There's so many sensors out there, and traffic engineers and roads and how much better are their systems performing with radar and with a good solution. I mean, it just moves the needle some.
It's statistical. So have you done the math?
I have not. No.
You have not. Okay. Is there anything else you want to talk about that we haven't discussed?
Yeah, the other application that we've been engaged in with radar and roadways is at railroad crossings, and so we've used radar to detect when there are vehicles on a crossing. And the primary application is to say, I mean, at some crossings when it's a high-speed at-grade crossing, or it's a quiet zone where you don't want the train to be honking their horn every time they came through there. You need some kind of secondary safety measures, and that might be channelization, or it could be exit gates, so that once the gates are all down, no one can drive through. And when they use exit gates, it's improved safety to detect and make sure there are no cars in that crossing or that island before the gates come down. So it's kind of another fun application where you can make things a little bit safer.
Is that a particularly challenging application in a different way than traffic?
It's challenging in that the rail industry has a very high standard for safety, and their standard is a 10 to the minus 9th failure rate. So you can fail once in 10 to the 9th hours for their system. So that's kind of an expectation or the bar, basically. So it's a very different environment, and a railroad crossing is very safety based, and so you can improve that safety, and then it's a win.
How do you see that changing or growing?
Well, the rail industry is changing probably as we speak, and they implemented positive train control, which put GPS on all the major trains, and they're tracking their route, and they have speed limits at different areas, and now they can communicate to a crossing and so they don't necessarily have to have track circuits or a circuit that detects the train on the track. They don't need to do that, and so I think the industry is moving that way. So there are opportunities to participate in that as well. So,
and that's got to be particularly satisfying for you to be a part of that.
Oh yeah, it's very interesting, and it's fun to again be part of like the beginnings of a company or the beginnings of an industry, and so that's exciting on the business side too.
When you stack up our radar against all the other forms of detection out there, is radar still more efficient, safer than others?
So radar, I mean, our systems have been proven and tested through multiple winters, multiple environments, and so we know what the performance is from our sensors, and I think we're just learning on a lot of the new entrants into the market. So
it's fun to hear stories of sensors that were installed 10, 15 years ago, still functioning, and the agencies have no reason to remove them.
Yeah, some of them, I think, 20 years ago. Yeah.
It's got to make you feel good.
Yeah. Yeah, and it's not our latest technology, obviously, but radar can be very robust and have a lot of longevity.
And like they say, if it ain't broke, don't fix it.
Right. Well, and that's the idea with radar is you kind of set it and forget it, and it just works. So.
Yeah. Well, Bryan, thank you for being with us, having a little chat about radar and traffic and technology.
Oh, you're welcome. Thank you.
I'm excited to see what's coming down the road, which you're not telling us about yet.
Yeah, it'll be interesting. It'll be
Some
fun.
good stuff. Okay.
Yep.
Thanks.
You bet.
And thank you for joining us for the Pulse podcast from Wavetronix. We'll see you next time.